Problem 72. Label the polar bonds and then decide if each molecule is polar or nonpolar. So I've copied the two molecules over here. The types of bonds that we have in this one, they're either carbon-hydrogen bonds or carbon-carbon bonds. So there are no other elements here. So we got carbon-carbon and carbon-hydrogen. Now using the figure 4.4 electronegativity chart, carbon-carbon, when you have carbon bonded to carbon, the difference is 0. So that is definitely non-polar. Okay, and then carbon-hydrogen, 2.5 versus 2.1, the difference is 0.4. So 0.4, and that's also non-polar because when you look at table, where is it at? Table 4.3, if it's less than 0.5, it's non-polar. It has to be 0.5 or greater to be polar. So there are no polar bonds in this molecule. And so I would say this molecule is non-polar. So what about the other one? You see the other one has carbon-carbon and carbon-hydrogen bonds as well. But it also has a new type, a carbon-oxygen bond. And you'll see carbon-oxygen bonds are definitely polar. Where is that chart again? Carbon's 2.5, oxygen's 3. So that's a difference of 1.0. And that falls in the polar range. The polar range is 0.5 to 1.9. So that's a polar bond. And since oxygen is more electronegative than the carbon, we will draw the dipole pointing towards the oxygen. So this bond right here is polar. Oxygen is pulling these electrons away from the carbon. And so there's an arrow pointing this way, and this is a polar molecule. The oxygen is kind of pulling electrons towards this end of the molecule. If you imagine, the molecule has this odd shape. There's all kinds of atoms connected together, kind of like that. The oxygen, the oxygen and there's more electrons on this side of the molecule than on the other side. So it's a polar molecule. All right, polar.